Hi, in this short video, I'd like to demonstrate how to run code simulation between XMODEL and SPICE. The example I'm going to use is a high-speed transceiver, which is made of this transmitter model using XMODEL primitives, a pair of lossy channels, and a continuous time linear equalizer block, and this final adder that measures the differential output of the equalizer. This continuous time linear equalizer, in short CTLE, actually contains two views, the schematic view and the XMODEL view. The schematic view describes this CTLE block in circuits using the components from the analog lib library. This topology is known as capacitive degenerated topology. On the other hand, the XMODEL view describes the same circuit in system Verilog syntax using the XMODEL primitives such as add and filter. The first step to running simulation is to generate Netlist. Glister, which is a custom Netlister provided by XMODEL, makes this process very easy for you. Since this CTLE_basic cell has two views that can be used for netlisting, users have two options when it comes to netlisting. To control that, you can create a configuration view by selecting this edit/view configuration item in the XMODEL menu. Selecting that item, it opens up a virtuoso hierarchy editor. What you notice is that the hierarchy editor has selected the XMODEL view for the cell CTLE_basic. In this mode, if you generate netlist by selecting this generate XMODEL netlist and display the resulting netlist, you'll find that the top level schematic, the TRX_CTLE_basic, is now netlisted in system Verilog format, and the CTLE_basic is also netlisted in system Verilog model using the XMODEL view. But if you use a different view for the same cell, let's say you choose a schematic view for the CTLE_basic cell, you find that it will generate a different netlist. Since we have selected the SPICE level schematic for that view, it will actually create a netlist suitable for code simulation. So let's see. The top level schematic is still netlist in system Verilog format. But for this CTLE block, it created two files. One is in system Verilog format, but it's actually empty. It only describes the input-output signals at the interface. The actual content is described by this CTLE_basic.sp, which describes the circuit in SPICE format, which are generated from the schematic you have seen. Now that we have generated the netlist, we are ready for simulation. To run XMODEL simulation, go to the XMODEL menu and select Run XMODEL Simulation item. It opens up this XMODEL test bench editor. The test bench we're going to use in this demo is called TB. In this simulation tab, you find that we are defining a few fields such as the simulator we're going to use, the duration of the simulation, timescale, and the extra option. This extra option defines the cosim control file named vcs80.init. Some of these extra files can be included as part of the test bench. They're listed as dependent files in this design tab. For instance, the vcs80.init file has a list of lines that define the SPICE engine, in this case XA, the top level SPICE deck, named tb.sp, and the extra configuration file for running XA. The second line says we're going to treat this CTLE_basic as a SPICE level cell. And these two final lines define the accuracy or tolerance options when signals pass between the analog and digital simulation engine. The XA_config file sets the simulation accuracy level of XA. And the tb.sp file lists the SPICE netlist generated by Glister and the definition for the SPICE model library used during the SPICE level simulation. The last tab, commands, defines the actual commands that are issued for running simulation and plotting the simulation results. The arguments we had defined in the previous two tabs are actually being used using these variables. Okay, so let's run this code simulation by clicking this icon that says Run Simulation. If you go to the command interpreter window, you'll notice is that we are running VCS simulation along with XA. The simulation is now successfully completed. To view the simulation results, you can click this icon that says Plot Waveforms. It will open up X-Wave Waveform Viewer, and you can select signals such as the output of the transmitter, the signal that propagates through the channel, and the differential output of the linear equalizer. As you notice, the transmitted signal is a nice looking NRZ waveform, but when it passes through the channel, it experiences losses. Some of those losses can be covered by this continuous time linear equalizer. Notice that the final waveform is a result of SPICE simulation. To be precise, is a result of XMODEL and SPICE code simulation. So in summary, you can run code simulation between XMODEL and SPICE. In this case, we have run the XMODEL test bench on a SPICE level cell. Glister, which is the custom netlister provided in the XMODEL package, helps to create these netlists required for code simulation very easily. Thank you.